filled in this time. So if you were asked to find the bearing of B from A, so as we said, this one's a bit trickier. It asks that you stand on point A instead, so stand here. So I've drawn that here. Stand on point A, face north, so draw in your north facing arrow and mark it as north. And then rotate clockwise to face B. So see this green rotation here. You're asked to rotate clockwise until you're turning to face point B, which is over here. Notice that this time the angle you measured, which is here, is a reflex angle, so greater than 180 degrees. Draw this information on the diagram below. So notice I did it over here, so mark in point A, point B, and mark in north and the line to point B and do the clockwise rotation arrow. It's a reflex angle, and notice what it's going to be worth if you need to work out what the angle is. It would be 180 degrees, so this straight line here would form 180 degrees, plus this little angle here. And this little angle here is 47 degrees, as you can see from above, because alternate angles, remember parallel lines, so you can form parallel lines from A to B. You've got parallel line here, parallel line here. If this one here is 47 degrees, then according to alternate angles, which you learnt back in Year 7 and Year 8, then this one here is also 47, which is why this little angle here is 47. So 180 degrees plus 47 degrees here is equal to 227 degrees, which is the value of that reflex angle there. And the reasoning is down here, alternate angles and parallel lines, so you might want to write down that too. Once you've done that, another example, find the bearing of B from A. So you have your diagram in orange here, B from A. So from A, meaning you start at A and you face north. So let's start at point A and let's face north. You can draw in the ends if you want, but basically face north, and then the rule is, remember, you have to rotate clockwise. So rotate clockwise to face B. So we're kind of going in this little direction here, and we've generated that angle there, theta. So that's what we've done here, a little instruction. What we need to do is we need to work out that angle there. But notice, remember, according to alternate angles again, this angle here will be the same as that little angle there. And if that whole blue angle is 200 degrees, we know that this segment is 180. So the missing part, 200 minus 180, is 20 degrees. So if that little angle there is 20 degrees, this angle that we want to know is the alternate angle to that angle, and that's also 20 degrees. To write as a true bearing, remember we have to write 3 digits, 0 to 0 degrees, and that's our answer for that, the bearing of B from A. Now similarly, let's do the bearing of A from B. So because it's from B, we have to stand at B and face north to begin with. So stand at B, face north, that's my red arrow there. Then turn clockwise to face A. So we're going to go around according to this green arrow, turn clockwise to face A. And as you can see, we already have the bearing. It was marked in on the diagram, it's 200 degrees. So the bearing of A from B is just 200 degrees, and that's already got 3 digits in it. So moving on to the last page. Another example, find the bearing of B from A. So B from A means start at B. B from A, sorry. So what we need to do is we need to stand at A, because it's from A, stand at A and face north. Stand at A, face north. Here's our little north sign if you want, mark that in. Then turn clockwise to face B. So I'm doing that through this blue arrow. So we're starting at A, facing north, then we're turning clockwise to face B, and B's over here. So that's why we draw the blue clockwise arrow to go that far. So what is the angle? Notice that this part here, it's a straight line, so it's 180 plus whatever this little angle is here. And let's try to think back to parallel lines again. Parallel lines, what's the relationship between this angle here and this angle here? Have a guess, starts with C. Yes, that's right, they're co-interior. Remember, co-interiors, they're not the same size, because one's acute and one's obtuse. They add up to 180. So if this one is 46, then this little angle here has to be 180 minus 46. So this little angle here is 134 because it's co-interior. They're both on the same side of the transversal and inside the parallel lines, so they're co-interior. So this whole blue angle is 180, because it's that straight part there, plus this little angle here, which is 134. In total, the bearing of B from A, therefore, is 314 degrees. And that's already 3 digits, so we've got a nice true bearing there. Then A from B, we're asked to stand at B and face north. So I've drawn in that red arrow there. Then turn clockwise to face A. Turn clockwise to face A. La la la, there's our lovely blue arrow. And that's a pretty easy one to get because this whole part is 180. So therefore the blue angle, which is the bearing we want, is 180 minus 46, which gives you 134 degrees, and that's already a true bearing because it's clockwise and also it's 3 digits. Here's another example. On a Duke of Edinburgh expedition, a student walks 2 kilometres south and then 3 kilometres east. Find the bearing of her finishing position from her starting point. Okay, so stand at the starting point and face north. So stand at the starting point and face north, then turn clockwise to the finishing point. So first of all, let's just map out her journey to begin with. So she was on a Duke of Edinburgh expedition, and just one second. Okay, so back to this question about the Duke of Edinburgh trip. So let's take the walk. So the student walked 2 kilometres south. So the student walked 2 kilometres south, which I've drawn in green, and then 3 kilometres east. So 2 kilometres south and then 3 kilometres east. So they went south and then they went east. And notice it forms a little right angle here. What we want to do is find the bearing of her finishing point from her starting point. So she started here. So you stand at the start and you face north. So I've drawn in the north facing arrow. Then remember, according to true bearings, you face north and then you rotate clockwise to face the other part, to face the finish point. So the angle we create as we face north and rotate clockwise is this angle here. So that's the angle that we need to find, which I've called theta 2 for some reason. So what we can do is we can work out this angle here. I've suggested one way we can do it is we can work out this angle here by using SOHCAHTOA, because we've got a right angle triangle. If we use this one, we've got the adjacent side and we've got the opposite side. So we can go theta equals tan minus 1, opposite over adjacent, because it's TOA. Tan minus 1, opposite over adjacent, and so using SOHCAHTOA, we've got theta equals tan minus 1, opposite over adjacent, and you get that this green angle here is 56.3, which enables us to work out what the bearing is that we want to find, because this forms a 180 degree straight line. So 180 minus 56.3 is 124 degrees to 3 sig figs. Alternatively, you could have also worked out this angle, but I personally found it easier to work out that angle using SOHCAHTOA and then just subtract it from 180 to get what the bearing is. So remember, that was the bearing of her finishing position from her starting point, which meant we had to stand at the starting point, face north, and rotate clockwise. So here is Natalie. Another example. Natalie steers the sloop. So Natalie, when were you on the sloop?
Last year.
And how did you find it?
It was
exhilarating.
And is this a picture of you?
Yep, that's
you?
me.
Were you steering the sloop?
Yep.
Oh, very good. Okay, so we've made an example about Natalie. Natalie steers a sloop for 70 kilometres on a bearing of... What bearing was it, Natalie, that you were
255 degrees.
Oh, okay, excellent. So that must be a true bearing. How far south of its starting point did you steer it? So what we've done here is we've drawn a diagram. Okay, and so what we've got here is Natalie... We've kind of tried to roughly draw in the bearing of 255 degrees. So we're assuming that here is the starting point, and 255 degrees, would you agree, rotate 180 degrees plus from 180 degrees, what extra angle do we have to rotate?
75.
Yeah, exactly, because 180 plus 75 is 255 degrees.
Yeah.
So in doing that, we can, and then notice that once she turned around, rotated 255 degrees, she then travelled 70 kilometres to here, her finishing point. So here's her starting point. So what we're asked is how far south of the starting point did she steer it? So we already know that the hypotenuse of this triangle is 70. So we want to know what side this is here. And we know this angle here is 75. And Natalie, this x, would you say it's the adjacent or the opposite if the angle is 75?
The adjacent.
Yeah, it's adjacent. It's touching the angle. Over here is the opposite, but we're dealing with the adjacent. So we want to find the adjacent side. And notice here we've also got a similar diagram. So a similar diagram where Natalie was here facing north. She went, I don't want to go this way anymore. And then she spun around 255 degrees and travelled 70 kilometres in that direction. And we want to find that length. So that's a shortened version of it. So we're dealing here with the adjacent side and the hypotenuse. So Natalie, would you use sine, cos or tan?
Cos.
Ah, yeah. Why did you choose cos?
Because we're using the adjacent and the hypotenuse.
Excellent. Yep. So let's do that. So cos theta, so we know our angle is 75 because it's 255 minus 180, equals the adjacent, which is our unknown side, how far south you're going to travel, over the hypotenuse, which is 70. And Natalie, how do we rearrange our equation? What do we multiply both sides by to get x by itself?
By 70.
Yeah! Okay, good. So we multiply it by 70. So x is 70 cos 75 degrees. Plug it into a calculator to 3 sig figs. Turned out that you are 18.1 kilometres south of your starting point. That's a long way, Natalie.
Yeah, long way.
Okay, so I'm guessing this happened. The alarm skipper suddenly realised Natalie had seized control. By the way, this didn't really happen. This is a fictitious story. But just for entertainment purposes, we're involving Natalie in this. So the alarm skipper suddenly realises Natalie has seized control of the ship. What direction must she sail to return the sloop to its starting point? So we're assuming like this was your start before, and you've gone all the way down to here. So what we do is we face north and we rotate clockwise. So that's what we always do. We face north from the point, rotate clockwise to the direction we want to turn to and head towards. So that's our little angle here. And remember alternate angles and parallel lines. So these two can form parallel lines, and this thing is a thing called a transversal. So that angle here we already knew is the same as this one here. And what was that angle equal to again?
75.
Yep, 75. So according to alternate angles in parallel lines are the same size. So what angle must that one be?
75.
Yay! And to make a true bearing, we just have to write it with 3 digits. So we write 075 degrees. Thank you for your assistance with this question, Natalie.
No problem.
Okay, and that's that. Bye-bye.